Halogen headlights are a shining example of progress. The halogen bulbs throw cool white light that mimics daylight, illuminating the road ahead. And because they're energy efficient, they don't burn out too often. That's a plus when you're trying to keep your eye on the road. To make a halogen headlight, mechanical jaws load 3 lead wires into a machine. A gripper moves in and bends the wires at the bottom. Meanwhile, a conveyor system feeds little glass rods to a burner. The softened glass is now pressed onto either side of the lead wires, encasing them. Next, a welding head fuses tungsten coils to the lead wire assembly. The coil is the filament, the part of the bulb that emits light. Over at another station, a mechanical arm loads a glass tube into a machine head. A burner aims a flame at the center to soften it up. Then mechanical heads pull the glass at both ends as the burner continues to fire heat at the middle. This creates a neck in the tube. Now mechanical arms position the coil and lead wire assembly under the newly shaped glass tubes. Grippers lower the glass tube over them so they sit under the neck. Burners move in and encircle the glass at the bottom, softening it. Then a press seals the glass around the lead wires, which protrude from the bottom. Next, a test. An electrode sparks the lead wires. When the capsule illuminates, it means there's ambient air inside that would interfere with the bulb's function. Vacuums at the top of the bulb suck out all the air and contaminants. Then nozzles spray liquid nitrogen onto the bulb. This freezes it inside and out, creating a pressure difference. That change in pressure pulls halogen gas into the bulb from a chamber above. Allowing no time for the gas to escape, burners heat seal the bulb at the neck. The bulbs then cool as they move on a transfer chain. Grippers now load the bulbs into another machine. A pusher moves up and snaps a steel retainer around the bottom of each bulb. Meanwhile, another machine builds the base for the bulb. It pushes electrical contacts into the plastic receptacle. This is the view from the bottom. These prongs will eventually connect the headlight to the vehicle. Next, jaws flip the bases. They load them onto a tray on tracks. The tray delivers the plastic bases to a mechanical arm that installs metal retainers on each one. The bases slide forward and the machine inserts the glass bulbs into them. But it's a loose fit. This machine aligns each bulb to its base. Jaws tilt and slide it into place, then a laser welds it together. This alignment is critical. Coils for the low beam and high beam mechanisms must be precisely positioned for the headlight to project the right light. Next, a series of claws pick up the bulbs. They dip them in an opaque coating. It's called black top because it only covers the tops of the bulbs. This will direct light out of the sides of the bulb. Now it's time to take these headlights for a test drive, so to speak. A bracket holds them down while probes underneath energize them to make sure they work. A plunger places a gasket around the base. This will seal the headlight capsule to the automobile. And now, They're ready to shed some light on any highway situation. The incandescent light bulb is a rather simple device. Its base has two metal contacts which connect to a metal filament. The electric current's electrons collide with the atoms in the filament, making them vibrate. This energy heats the atoms to 2200 degrees Celsius, at which temperature they emit visible light. The light bulb factory has two production lines that eventually merge. One prepares the glass bulb, the other makes what's called the mount, the electrical components that go inside it. At the start of the mount line, a machine cuts glass tubing into pieces of specific lengths. The cut tubes land on what's called a glazing wheel that runs them through a gas flame for about 7 seconds. This heats the glass enough to smooth the surface. The glazed tubes now enter what's called a flare-making machine, which heats each tube until the glass is malleable, then stretches one end into a flared shape. The next machine loads 2 copper lead wires into the flare end. Then it inserts a thin glass cylinder called the exhaust tube. A trip through a series of progressively hotter flames softens the tubes. A press then moves in to squash them, encasing the wires in glass. At the same time, the machine makes a tiny hole in the glass in between the wires. This is to later remove air from inside the bulb. It'll exit via the exhaust tube through this hole. Next, the machine separates the lead wires and forms the ends into hooks. These fasten to the filament, a thin wire coil made of tungsten, a type of metal that holds up well to heat. The machine coats the lead wires in a liquid form of another metal, zirconium. This lengthens their lifespan by making them more resistant to moisture inside the bulb. Like the tubes we've just seen, the bulbs are made of an inexpensive type of glass called soda lime glass. A machine stamps the top of each bulb with the voltage, the wattage, and the company logo. Opaque light bulbs are simply clear bulbs with an inside coating of synthetic silica, a white powder. The coating machine charges the bulbs to 30,000 volts. Combined with just the right amount of heat, this electrical charge makes a thin layer of powder cling to the glass. A series of flames evaporates moisture and bakes off any impurities. As the two production lines merge, a bulb goes over each mount. Torches then fuse the flared end of the mount to the neck of the bulb. Arms move in and mold the neck to fit inside the bulb's aluminum base. The next machine vacuums out all the air in the bulb and replaces it with pressurized argon gas. This inert gas will resist heat buildup, helping the filament last longer. After bending the lead wires out of the way, torches melt and seal off the glass exhaust tube, locking the argon gas inside. The bulb would now be fully functional if connected to an electric current, but it needs a base in order to screw into the socket of a light fixture. The base is made of aluminum. This machine inserts one of the bulb's lead wires through the middle and solders it in place. It then spot welds the other wire to the side. The result? 2 base contacts to line up with 2 socket contacts. On their way to packaging, the bulbs undergo what's called flash testing. Repeated light-ups using a higher voltage each time. This strengthens the filament inside, making it less likely to break during shipping. This factory tests light bulbs regularly to make sure the light output and wattage are what they should be. One last illumination to make sure nothing broke between flash testing and packaging. The automated packaging equipment is designed to have a light touch, so to speak, handling the fragile bulbs with care.